What's up, mathematicians? Justin here. Would you like to see something truly beautiful? Let me show you something. Get this lined up here. All right, so I've got my nifty little tool, and check this out. Look at that. This might just be the most beautiful shape that there is, but how do we measure it? So that's what we'll be talking about in this lesson, which will be lesson number 9 on our measurement on unit, which is about circles. Now, before we get into measuring circles, let's be clear about what a circle is. So I have this little definition for you, and it says that a circle is the set of all points that are the same distance from a center point. Okay, and let's look back at the little picture with the compass here, and we can see here that one way to construct or draw a circle is with a compass. The reason is that the compass has this point right here, which stays at the center of the circle, and it keeps the same distance as you draw the circle. So while the point of the compass stays at the center, the marker or pencil or whatever you have here at the other end draws out all the points that are the same distance from the center point. Okay, so in order to measure a circle, we will need to know the center. And you probably can't see it in the video, but there's a little hole right here that was left by the compass. I'll go ahead and draw a dot right in there. So that is the center of this circle. If there is no hole, or if you can't find it, or if you're just given a circle, not one that's made with a compass, there are ways to find the center. You can use a compass and straight edge to construct the center. We won't get into those types of constructions until unit number 3. Now let's go ahead and review a few terms as they refer to circles. So the first term that I want to share with you is this. So if we take a straight edge and draw a line from the center of the circle to a point on the circle, that distance right there represents the radius of the circle. I'm going to go ahead and abbreviate with an R. Now I'm going to go ahead and grab a different color here, and let's see, here we go. Now I'm going to draw a line that goes from one end of the circle through the center to the other end of the circle. This line actually divides the circle into 2 equal halves. So that line right there is called the diameter of the circle, and I will go ahead and abbreviate that with a D. Finally, the distance all the way around the circle is called the circumference, and I'll go ahead and abbreviate that with a C. Okay, now I can easily measure the diameter with my ruler. So for example, I'll take my ruler right here, I'll line it up, and I see that in this case, the diameter is about 103 millimeters, about 10.3 centimeters. However, what if I wanted to measure the circumference? I wouldn't be able to use this ruler, right? This wouldn't do me much good because the circumference is not straight, okay? Now, interestingly, to measure the circumference, we actually will not come up with a technique as we did for triangles and rectangles. Instead, we will make a key assumption. We will assume that all circles are similar, whether you have a tiny little circle or a huge circle the size of, the universe or something. We will assume that all circles are similar to each other, okay? And what follows from that assumption is that they will have the same proportions, right? So a small circle will be proportional in all respects to a very large circle. And we will define a ratio between the diameter and the circumference. And this, as it turns out, is where pi comes from. Okay, so you may have heard of this little symbol. Actually, let me pick a different color. Use different colors here for the different things. So, you may be familiar with this little symbol pi. You probably are. And we make this definition saying that, okay, we'll go ahead and define this following ratio. So we have pi is equal to the circumference divided by the diameter. Okay, so instead of coming up with a technique, we'll just say, hey, we'll assume that all circles are similar, and therefore the ratio of the diameter to the circumference, or I guess maybe I should say the circumference to the diameter, will be the same in all circles, and we'll go ahead and just call that ratio pi. So by the definition of pi, we can set up an equation to determine the circumference. Algebraically, you could think of this as just multiplying both sides by d. So we'll say circumference equals, and I'm going to switch colors here. I'll just say circumference is equal to pi times d, pi times the diameter. Okay, so there we go. Now we know what the circumference is. Kind of. I mean, do we? What if I want to know the circumference of this circle right here? I already measured that the diameter was, what was it again? About 103 millimeters, I believe. Yep. So let's go ahead and write that in. 103 millimeters. But without knowing the value of pi, I'm not going to be able to determine the circumference of the circle. Okay, so what does this mean? This means we need to know, well, naturally, we need to know what pi is in order to be able to find the circumference. And there are a few different ways to go about that. Okay, one is to go out and do some measuring and calculate it ourselves. Another is to look it up. And let's go ahead and try both. So first, I'm going to do the measuring approach. I'm going to take this lovely mug. Look at it. This is a gift from a student of mine, former student of mine actually. Maybe the best gift I ever got. And I'm going to take this mug. It's pretty cylindrical, as you can see. So it should work pretty well for this measurement. So what I'll do is I'll take this flexible ruler and I'm going to go ahead and measure the distance all the way around the mug. All right. And if you look right there, I don't know if this is coming. Okay. So that is 303 millimeters, 30.3 centimeters. So the distance around this mug is 303 millimeters. And now let's find the diameter of the mug. Now, this may not be perfect because I have to try to find the exact middle here, but to me that looks like 96 millimeters. Okay, so I can use that value, those values, to calculate pi. Let's go ahead and plug it in my calculator here. And let's see, so what did I say? 303 divided by 96. And I don't know if that shows up very well. You know what? I got this new calculator. This new company, NumWorks, is making these graphing calculators, trying to compete with TI, and they're sending them to teachers for free. And it's a nice calculator, but unless I can figure out how to make this dimmer, I might have to use my other one. Hang on. All right, let's do that calculation again. So what was it? 303 divided by 96, and we get this number right here, 3.15625. If I abbreviate that to the nearest hundredths place, what that's going to give me is the following value for pi. I'm going to get that pi is equal to, I'll say approximately equal to, 3.16. And okay, so now it's pretty simple to find the diameter, right? Or sorry, the circumference, because I know the diameter is 103, and I know that pi is about 3.16. So I'll say, okay, the circumference is equal to pi times the diameter, so 3.16 times the diameter, which is 103 millimeters. And if I plug that in my calculator, so I'll go ahead and just type it straight in. So what did I say, 103 millimeters, and I get 325 all around to the nearest tenth of a millimeter. So what that means is the circumference of this particular circle is more or less, rounded to the nearest tenth of a millimeter, 325.1 millimeters. Okay, so that is how we measure the circumference of a circle. We go ahead and define the ratio pi to be circumference to diameter, and then we calculate it, or, as you probably know, you could also look it up. I'll go ahead and look it up with my calculator here by just typing pi in and hitting enter. Now we say that my calculator says gives the value of pi as 3.1415926.5, and then it goes on. It would continue on and on, but usually to the hundredths place, 3.14 is considered good enough for most applications. And so if I go ahead and use that value, I'll say, okay, multiply pi times 103, and I'm going to get 323.58. I'll round that off to 323.6. So the circumference with the value of pi that I got with my flexible ruler, measuring the mug, it's not bad, but it's not perfect, is a little less accurate than this circumference right here, 323.6, but close enough, both within less than 1% of each other. So there are certainly other methods to calculate the value of pi that I'm not going to get into in this video. Archimedes was an early pioneer in this endeavor. I have Archimedes' book right here, which talks about Archimedes' computations of pi. And Archimedes used a 96-sided polygon to calculate that the value of pi is very close to 22/7. It's not exactly that, but that is to this day still commonly used as a good enough approximation for pi in many situations. Go ahead and plug 22/7 in your calculator and see how close the value is to the actual value of pi. But now that we know that what pi is, or at least we have a good estimate, we're able to measure the circumference of a circle, so that's great. But how do we go on to measure the area of a circle? So here's a circle, and how could we find the area? I wonder, what if we could somehow make a square? I'm freehand drawing this, so it won't be perfect, but do you think maybe we could make a square that had the same area as the circle? It would, have, like, this distance would be a little less than the diameter, but the corners would go a little bit past. Well, it turns out this is an ancient problem, turning a circle into a square of the same area, and it's a pretty difficult one. So you can look that up if you're interested, the squaring the circle problem. But it's much easier to actually take the circle and turn it into something close to a rectangle by doing some slicing. Okay, so I drew a bunch of slices in this circle. Now I'm going to get my scissors and cut it all out. Okay, so I've been cutting these slices out and then arranging them into a somewhat rectangular shape. So let's see, I got my last couple slices here to cut. And I'll add them to the shape. So you can see here, I've taken the slices that were originally part of that circle, cut them all up, and rearrange them into something that looks, not too unlike a rectangle, maybe more like a parallelogram. You could imagine, maybe I'll actually even do this, I could cut one of these slices in half and put one half on each end. So here, I'll go ahead and do that. So I'll put one half of that slice there, and the other half right over here. And now you can see it looks even more like a rectangle doing that. And you can probably see how and again, using pencil or paper and scissors, you're not going to get super precise with this necessarily, but you can at least imagine how the thinner and thinner these slices get, the closer and closer this rearrangement is going to be to an actual rectangle. These little curves here on the ends are going to get to be really small, and so they'll end up making more or less a straight line. So now that we have this rectangle, let's figure out what the area of the rectangle is. Because if we used the circle, if we cut up the circle, rearrange it into a rectangle with all the pieces, then the area of the rectangle should be the same as the area of the original circle that we started with. So thinking about this rectangle, let's go ahead and find the base and the height, or the length and the width, and calculate the area of the rectangle. So first of all, this length right here, the height of the rectangle, well, that's just going to be the radius. So let's put right here, area. And right here, because this point right here was originally at the center of the circle, and this point right here is on the circle itself. And so the distance from the center to the circle is the radius. So area is equal to the radius times, well, let's think about the base, right? This whole base right here is equal to half of the circumference. So if you know the circumference of the circle, you can take half of it, and that will be the length or the base of this rectangle. So I'll put in here 1/2 c for circumference. Well, let's do a little substituting, because having multiple variables in here, while it's still a formula that we could use, is maybe not as simple as we would like it. We'd like to be able to plug in one number instead of multiple numbers if possible. So we know that the circumference is equal to pi times the diameter, right? So what if instead we say, okay, r times 1/2 pi d? Well, that doesn't really solve our problem, right? Instead of having r and c, we have r and d. We'd like to have just one variable, but recall that while the radius is the distance from the center to the circle, the diameter is the distance all the way across the circle, going through the center. And so the diameter is equal to 2 times the radius. Okay, well, now we can take this 2 times the radius, and we can substitute it in for diameter. And so we see, okay, now we have r times 1/2, and I'll put the 2r first. So let's see, times 2r times pi. Well, 1/2 of 2 is going to be, 2 divided by 2, which is 1. So these go away. And so we have r times r. And so we're left with the following area. Area is equal to pi times r, which is r squared. And so we have this formula right here, that the area of the rectangle is pi r squared, and therefore the area of the original circle that I started with would be pi r squared. Now, you've probably already heard of this formula, but I felt like lesson on circles, can't pass up the chance to go through one way to come up with this formula. But there is something I personally find fairly fascinating about this formula. So notice that this formula has a pi in it. But what is pi? Pi is a ratio between the length of the diameter and the length of the circumference. And so this ratio between lengths somehow also shows up in the formula for the area of a circle, which isn't necessarily obvious. Kind of fascinating, kind of interesting, actually, in my opinion. I wonder why pi ends up in the formula for the area as well. Just something to think about. So just to review, the key formulas to take away from this lesson are relating to circles are this, that the circumference of a circle is equal to pi times the diameter, or written another way, the circumference is equal to 2 times pi times the radius. So either of these formulas will give you the circumference, and then of course the famous formula for the area of a circle is pi r squared. So also note that once again, our solution to finding the area of a non-rectangle involves turning that non-rectangle into a rectangle. We've seen this before, right? These area formulas always seem to go back to rectangles. So to measure the area of a triangle or a parallelogram, and now a circle, etc., involves taking these things that are not rectangles and turning them into rectangles so we can measure their area. Even the branch of calculus, which involves finding the areas of irregular shapes, bounded by these, harder to define curves, starts by chopping these shapes into thin rectangles, finding the areas of the thin rectangles and adding them all up. So rectangles, it turns out, are really powerful tools for finding the areas of different shapes. So that'll wrap up this video. In the next video, we'll look at some more involved calculations for measuring parts of circles rather than the entire circle, which is what we focused on in this video. As always, thank you so much for watching. If you learned something today, please do like and subscribe, and I will see you in the next video. Bye-bye.